This is Jake Anderson at the Infrasound Lab at Boise State University, and I'm just talking about how to use the GEM Infrasound logger. So this is the logger. Important things to check for before use are that the SD card is in, that the filter here is on the correct port, so the one to the right in this view, not the one on the left. If you switch it, it'll reverse the polarity of the signals, and that all the boards that are on this are firmly attached. This particular GPS is soldered on, but not all of them are, especially in these experimental versions. Before using the GEM, you'll want to make sure that there is a micro SD card in the slot and that the filter is on the correct port, as shown here. The next step is to connect the battery. We've got two cords for that. You'll want to use this one with the 9-volt clip. This one in the background is for rechargeable batteries, which we're not using in this case. My personal favorite battery pack to use is this set of 3 D cells. It fits right in here. And you can just clip the cord on, and that's enough to power it for about 2 to 4 weeks. If you want to fly it, though, you're going to want to use a 9-volt battery, specifically a lithium 9-volt battery, to save weight. An alkaline 9-volt battery, that's what I'm demonstrating with, that won't last very long. Lithium 9-volt battery will last somewhat longer. Once you connect power, you'll see that the LED on the GPS starts blinking. That means that it's looking for a fix when it's blinking every second like that. Once it finds a fix, it starts blinking once every 15 seconds. In order to start acquisition, you just find this little black switch here and flip it from stop to start. Then the blue light starts blinking. That's good. Once it starts blinking twice, that means that it's waiting for the GPS to start acquiring. That happens 10 seconds in always. Once it does find a fix, it will start blinking 3 times in a row, and it'll do that for about 20 seconds, long enough to collect 20 data points from the GPS, and then it'll turn the GPS off in order to save power. It'll turn the GPS back on every 15 minutes and collect 20 more samples and then turn it off again. And this is enough to maintain time accuracy while saving a lot of power. Once it starts logging and you're satisfied with it, you just close the lid and snap it shut, and it's ready to go. When you're done acquiring data with it, you open the lid, and just flip the switch back to stop. And then you can disconnect power, and you're all done. Just pop the SD card out in order to analyze the data. This is the setup that you can use for the system that's going to fly on the balloon. It uses a different enclosure just to save weight. This one is a little less sturdy than the other one, but it's way lighter. It's basically the same setup. Here we have the 9-volt battery secured with a little rubber band here, and otherwise it's the same. There's some tape on this to hold the GPS and analog digital converter in place, just because this platform is presumably going to be wobbling around a lot on the balloon. The only thing to be careful of here is you've got 2 holes on this side. These should face downward so that you can have a connection to the atmosphere without water draining in there. And then the GPS needs to face roughly upward in order for it to get a good signal. And that's it. So once you start logging and you're satisfied that it's working correctly, just pop the lid on. do what needs to be done to secure it, and then attach it to the balloon however you're going to do it in this correct orientation. Good luck.